In this video, we're going to do an example of the method of integrating factors, which is the method that we're going to use to solve first-order linear differential equations. Now, the reason this is a linear first-order equation is because the coefficient of y prime, the coefficient of y, and the coefficient of 1, I could come on the right-hand side and sneak an extra 1 there. The coefficients of all three of those are just some function of x. And indeed, this is in standard form, and the coefficient function of y is typically called p of x, and the coefficient function of the 1 is referred to as f of x. So I'll just put the standard labels. But either way, the 1, the y, and the y prime all are to the power of 1 with coefficients, and those coefficients are some functions of x. Then the formula for the integrating factor was that r of x was equal to e to the power of the integral of p of x dx. Okay, so in this case, that's the same thing as saying e to the integral of 4 dx, which is the same thing as saying e to the 4x. And you might notice it's an indefinite integral, so you might have wanted to put a plus c. We're just looking for any integrating factor that works, so I'll just choose arbitrarily that c is equal to 0 and not worry about it anymore. Okay, so the next step I want to do in my method of integrating factors is a little bit up to you whether you want to write it down or not. I like to because it reminds me of why we're doing what we're doing. But what I like to do is I'm going to copy down the equation, and I'm going to leave a little bit of a space there, and a little bit of a space there. And the method of integrating factors is all about taking every single term and multiplying by that integrating factor. I'll put an integrating factor there, there, and there. Maybe I'll just do a little simplification on the far right-hand side and see that e to the 4x times e to the minus x is the same thing as e to the 3x. I can simplify that on the right-hand side. Now, the next step is to simplify the left-hand side, and this is where it gets kind of interesting. I'll notice that the following is true. This is the same thing as the derivative with respect to x of e to the 4x multiplied by y. And you can verify by the product rule that you'd get exactly that. And indeed, when we introduced this method of integrating factors, we defined the integrating factor so that this would always be true. So it was always going to be the case. It was the derivative on the left-hand side and then some function which is on the right-hand side. Okay, so now I'm going to integrate, and that's going to give me on the left e to the 4x times y. All I'm doing here is just integrating a derivative, so it cancels. And then this is the same thing as the integral of e to the 3x dx, which is 1/3 times e to the 3x. And now I am going to write down a plus c. You might think this is a little bit odd. I told you earlier you didn't need to write down the plus c, but you didn't need to write down the plus c earlier because it was all about finding an integrating factor. And in an integrating factor, we just wanted any one that worked. Indeed, if you had a plus c that was sticking out there, it would have canceled the next line anyways. But now I'm going to my solution, and what I've gotten is this expression that has an indefinite interval. I do want my plus c, and my plus c will be useful for my initial condition. Well, final answer, I notice that I have this e to the 4x stuck still on the left-hand side. I don't want that, and so I'll say that y is going to be e to the minus 4x multiplied by the 1/3 e to the 3x plus the c. And if you prefer to distribute this through, that's totally fine as well. You can do 1/3 e to the minus x plus a constant times e to the minus 4 times x. All right, so that's my general solution. But I do want to go back to the beginning to remind ourselves that, in fact, we actually also had this initial condition that y of 0 was equal to 4/3. So let's see how we can deal with that. I'll scroll back down. And what I want to plug in is that y at x equal to 0 is equal to 4/3. And so that's the same thing as 1/3, well, e to the 0 is just going to be 1 plus a constant, e to the 0 is another 1, so this is just going to be 1/3 plus c. And this is the same thing as saying here that c is equal to the value of 1. And so if I want to put this together with the value of y that I had just computed, I can get my final answer. Here it is, y is 1/3 e to the minus x plus c is equal to 1 now, e to the minus 4x final answer. And that is the method of integrating factors.